I've been telling y'all Friday we're gonna do that the benchmark, but I just now realized while I was out in AEP that we may not have to do the benchmark in this class. I think I only have to do it for one like prep, so it's probably gonna be for chemistry. So we might just have something else to do for Friday. Know that it very well could be another assignment just like this. So make sure you're paying attention today. You understand how to get to the assignment, how to complete the assignment, because you might have one on Friday with the sub. I will still post instructions on Google Classroom. I might even make a video to go in Google Classroom to kind of go along with the reading. But you got to make sure that you're doing this. So real quick, everybody, look up here and listen. This class in particular, this is my Earth and Space class, like 90% of y'all, maybe more, are seniors. Y'all are ready to get out of here. Nobody's interested in geology or Earth and Space. This is literally like, I know what's up. Y'all took this class because you didn't want to take physics or anatomy. I understand. That being said, every single year, I have this class packed with seniors, and a bunch of y'all just don't complete assignments. You sit there on your Chromebooks and you watch YouTube and you do other things. I'm going to do my best to make sure that I'm on top of you and making sure you're turning in assignments and getting stuff done. That being said, if you wait until the end of the year and you're like, oh, I got to pass, and I look at your grades and you have like 15 zeros, there's not a lot I can do to help you. These are very easy assignments. Most of the time, I will give you all the answers directly. So make sure that while I'm up here, you're listening to me, you're paying attention, and you're getting the assignment complete. And then at the end of the year, you won't have anything to worry about. You can just graduate and get out of here, and you won't ever have to see me again. So first thing, go ahead and get logged into the Google Classroom. So this is your Google Classroom for the year. This is the code. Go ahead and go to Google Classroom, put it in, and get logged in.
Really?
I'll write it up here for any stragglers. U N 7 N F FDW. Okay. So everybody good on this? Anybody still working on the Google Classroom? Okay. So now, open up a new tab in your Chromebook and hit the home button or go to ClassLink if you have that bookmarked. But if you hit the little home button up here in the top left corner, it should take you directly to ClassLink. You may have to log in. Go ahead and log in. Listen, this is the way I show you how to go to the book at the beginning of the year. And the reason is, if you go through it this way, you put your password in once, you never have to remember your password again. It's saved forever, and it just makes things that much easier. So if you'd like to save it as a bookmark or save your password through Chrome, that's fine. Do it however you want to do it. Just make sure you know how to get to the program, you know how to get to the assignments, and you're actually getting things done. So the book is Discovery Education, just like you used in biology class with Mrs. Sell. Click on textbooks. Click on Discovery Education. And if you've used it before, it's possible your password might already be saved in here. If it is, it'll go in and you should already be in the class. If it's not, how many people do not have their password saved? Just a couple. All right. Here is your password information. It's going to be your ID number and PISD as your username. And then your password is just going to be your ID number. Yes.
Is the PISD capital or no?
Yes, capital. Capital PISD after your ID number and the username. And then the password should just be your username. And if you're putting it in for the first time, or if anybody didn't get logged in properly, if it gives you an error or something, let me know. Because I can go ahead and fix this, and then you won't ever have to worry about your password again. So password for Discovery Education, your ID followed by PISD, and then your password should just be your ID number. Okay, so now that we're all here, what you should see, hopefully, let's see.
It says view assignment.
Yeah, you have an assignment. usually it gives me an option to view things just like y'all do. Let's see. There we go. Turn the teacher view off. Well, no. Oh yeah, hold on. I'll have to do this later. Anyways, you have an assignment. Go ahead and click on the assignment. What I've done here is I've just assigned the reading for you. We're actually going to go over it as a class. I'm not going to have you sit here and read all this by yourself. We're going to talk about it, watch a couple videos, and then we're going to do an actual multiple choice assignment. The multiple choice assignment isn't up yet because I want y'all to pay attention while we go through the reading and everything. So everybody has this pulled up. Did everybody get to this page? No? Did you get logged in? Let's see. Oh, wait. Maybe I don't have to go in the class. Let's see if I can fix this real quick. I should have everybody. You should be in the class. Hold on. My classroom. Give me a second. Let me look. All classrooms. This classroom. Oh, never mind.
You had my sister.
Yeah, my bad. I just saw the last name and I clicked on it and, you know. So let me see real quick. I can get you in here, I think. You're going to be in the S's towards the end.
Why are my shoes on one side?
That's the T's.
Imagine on one side.
Come on. There we go. Let's see. Where you at?
I don't know.
Where are you going?
I think it's on next page.
Oh, there you are. They have your first name and your last name mixed up. Okay. So maybe reload the page now. And hopefully you'll be in it now. Okay. Oh, I'm coming.
That's what I'm saying. Yeah, it's not there.
It's probably because you weren't in it when I actually assigned the assignment. So you don't really need to get to it. Just know that you're in the class now, and the rest of the assignments should show up. So when I put up, because you're not going to actually read this yourself right now, when I put up the multiple choice in a minute, let me know if you don't see it then. All right. So look, now is everybody to this page? Okay. So on a normal assignment, I would assign this if I'm here. I'm going to go ahead and go through it with you. We're going to watch a couple videos. We'll talk about some stuff. If I'm not here, what you're going to do is you're going to read through this yourself a little bit. And here's the thing. I'm trying to set y'all up for this because I noticed a lot of patterns last semester with this class. It gets to be a little bit easy. And what y'all get in the habit of doing is not reading any of this stuff and just going into the multiple choice assignment and starting on the multiple choice assignment. Normally that's fine, but the questions are kind of hard. They're very specific. And what I noticed in last year's class was a pattern of people just getting on here and guessing their way through the multiple choice assignment, which A, you're not learning very much, which I know y'all don't worry about too much. But B, it's not like Sapling where you get a lot of guesses. You get one guess on each question and you turn the assignment in and you don't get to try it again. Now, if you want to do an assignment again, you can come in during activity period. I will open it up for you. But I'm not going to let you like guess your way through it the first time just to reset it and get a second chance at it. So take your time. You can actually open up both tabs. You can have the reading open in one tab and the multiple choice assignment open in another. Go back and forth between the tabs and hunt down the answers if you're doing that. But don't try to answer all the questions without at least having the reading open and looking through the reading to try to find some of the answers. I will also say most of the time, the questions are in order in the reading. So if you start on question 1, it will probably be towards the top of the reading. And as you go to question 2, you'll just go down the reading and they kind of go in order unless they've changed that recently. So now that everybody's on this page, let me go through this, and then I will assign the multiple choice assignments, and y'all can keep going. So everybody close your Chromebook. Close your Chromebook. Close your Chromebooks. And let's actually look at this and talk about this together. It should go pretty quick because we actually did talk about a lot of this yesterday. So mostly what we're going to see that's brand new is the videos. This chapter is basically just setting up the different branches of earth and space science and geology. So like yesterday we talked about astronomy. What do astronomers study? The stars and space. So all of space. You could even throw in other planets and stuff in there. Geologists are going to study what? Rocks, but also the entirety of Earth. So geology is like the big umbrella term that includes all the Earth's physical processes. If you're just studying rocks alone, that's probably called a petrologist. So petrologists are going to be rocks only. Geology, as it says right here, is a broad category. It includes multiple different things, not just the rocks. What do paleontologists study? Fossils. So yesterday I had it listed as dinos. No, it's not just dinosaurs. It's all fossils. Any kind of fossils you have, that's a paleontologist. Oceanographer, what do they study? Oceans. I almost said oceanography. Let's see. So if you keep scrolling down, when you get to the multiple choice assignment, this chart will probably help you out quite a bit. It has all the different types of scientists, what you call those scientists, and then what they study. So if you see a term that you're not really sure on, like petrology, we talked about that a little bit yesterday, but it's probably not one you're familiar with. You can come down here and see, petrologists study just rocks. They don't care about water or erosion or anything like that. They just study the rocks themselves. So let's see. Then they get into the history. A couple things I want to point out. People have been looking at the Earth and the stars for a very, very long time. It's just natural. You walk around, you notice things, and you might wonder out loud a certain question. Maybe you don't know the answer to it, but people have been thinking about this for as long as we've been alive and been smart. We've been thinking about what space is, what the Earth is, what the stars are doing up there. We based our calendars off the stars. There are religions that are based off celestial objects and different things. We know the Greeks and Romans all had different gods associated with all the different planets and several different stars. So we've been doing this for a long time. The original people that started it, as far as we can tell historically, were the Babylonians about 6,000 years ago. Is Babylon still a country? No. This is like, what's Babylon? Babylon's going to be like, no, this is like Middle East, kind of Europe area. No. Well, no, Asia's not really Middle East. Middle East, like Europe and then like the upper part of Africa and the western part of Asia. And then not too long after that, the Chinese started to take some scientific measurements of the Earth and the stars. Is China still a country? Yes. And so in many ways, even though China didn't necessarily start on the science the earliest, they're the ones that possibly have the most complete records. In fact, one of the oldest celestial records ever, I think is like an assistant to a Chinese king. And he was basically like writing down a diary of what the king did every single day. And he remarked on a weird time when the sky was like super bright and there was no night for like 2 weeks. It was like daytime all the time. And it was really weird. And the guy wrote it down in his journal. And we've kind of pieced together that he was one of the first people to record seeing a supernova in the sky. And so he was actually seeing a star exploding, and it was making everything much, much brighter. Without his records, he didn't know what was going on. He had no clue what was happening. But through reading through his records and using modern day science to try to figure out what would have happened around then, we've kind of pieced that together. So we're going to watch this short video, 5 minutes, on the history of space science. And then there's another video that's like 3 minutes long. So these won't be too bad. I'm going to pause this so YouTube doesn't take my figure out. They took really, really good measurements. And so later people were able to come behind them, look at their measurements, and actually figure out a lot more with new technology and new understanding. So Tycho Brahe took a lot of measurements. Kepler gave us the 3 laws of planetary motion. Basically that when the planets orbit the sun, it's not a perfect circle. It's more like an oval. In that oval, the planets go faster the closer they are to the sun, and slower the further away they are from the sun. And same thing, the planets that are further away from the sun travel much slower and take longer to go around. For instance, how long is a year on Earth? 365 days. And that's the amount of time it takes the Earth to go all the way around the sun once, right? How many days do you think it takes Mercury to go all the way around the sun?
Longer.
No.
Oh, no, they're closer.
It's closer, so it's going to go faster. So in Earth days, which Mercury days are different, but in Earth days, Mercury goes around the sun every 88 days. So less than 3 months is a Mercury year. Now let's go all the way out to Pluto. Guess how long it takes Pluto to go all the way around the sun?
2 years.
No.
No.
248 years. 248 years. And I don't know the exact year, but Pluto was not discovered that long ago. So since we have actually seen Pluto and know that it's out there, it hasn't even gone a quarter of the way around the sun, let alone an entire loop around the sun. So there's a lot of weird things going on in space, and we haven't been looking for that long. Even though as humans we've been doing it for like 4,000 years, that's not very long when you talk about the things that are going on out in space. Galileo Galilei, what did he invent? He didn't invent it, he made it better. Telescope. He designed one of the best early telescopes. And with that, he discovered all sorts of stuff. The first 4 moons of Jupiter, the rings of Saturn, all sorts of things he saw for the very first time. Yeah, the phases of Venus. He was a space explorer, even though he never really left Earth. Newton. What did Newton give us? Gravity, which for Newton, it was, for when we think of gravity and Newton, we think of like the apple falling on his head and gravity here on Earth. Really what gave Newton these ideas was looking at planets and stars out in space and trying to figure out what was going on with them. Let's see. Hutton, uniformitarianism, catastrophism, theory of evolution. Let's talk about these for a second. Just looking at this word, uniformitarianism, what's the beginning part sound like? Uniform. And what does uniform mean? Like the same. Yeah. Even if it's like a school uniform, the reason they call it uniform is because everyone's dressed the same. So uniformitarianism is an idea in earth science that the way things happen today, they've always happened. So if I go outside and I look at water running down a river, or I look at sand blowing in the wind, or trees in the rain, I can guess that it doesn't matter how many millions of years I go back. Maybe the trees looked a little different and the rivers might have been bigger or smaller, but the water's going to move the same way. The sand is going to move the same way. The same things are going to happen, just like with gravity. That's the opposite of catastrophism. Catastrophism is the idea that the earth is very young and that all the things that happen in the earth, like the Grand Canyon or giant mountain ranges, those were formed over a very short period of time. So like the Grand Canyon would have been carved out in a couple years instead of thousands and thousands of years. So like mountain ranges would have not been there one day, and then there would have been a huge mountain range the next day in huge catastrophic events. Now, we don't see that happening today. We've never seen on Earth, as long as humans have been here, we've never seen a mountain range just pop up overnight or a giant chasm be like eroded out of the ground in just a couple of days. It takes thousands and thousands or hundreds of thousands or millions of years for these things to develop. So uniformitarianism is what we're using right now. What did Darwin give us? Evolution. And evolution doesn't have a lot to do with rocks or the earth per se, but evolution helps us understand how old the things that we're dealing with are, and how these changes can happen very slowly. Let's see. Alfred Wegener gave us continental drift. In the hypothesis of continental drift, what do you think the continents are doing? They're drifting and moving around. What do we call that today? That the continents move around. Does anybody know the name of it?
Drifting.
No, not the drifting part, but the scientific theory part.
Tectonic plate.
Yeah, it's the plate tectonics. So
Plate tectonic.
continental drift is where we started out. Now we know it's plate tectonics, and I need to get my globe out. But plate tectonics is the idea that all the continents are moving. The North American continent, the United States, where we are today, used to be attached to Europe and Africa. We used to all be one piece of land. Now we've pulled apart. If you keep fast forwarding, we are getting closer and closer to Russia and Asia. And the Pacific Ocean is getting smaller and smaller and smaller. And so if you were to get in a time machine, travel forward probably like, a couple 100 million years, the Pacific Ocean would be much smaller. The United States and Russia would be connected together by land. And who knows? Maybe we'll be friends. Maybe we'll still be enemies. Let's see. Bowen, we'll talk about Bowen later. He figured out some stuff about rocks. Let's watch this short video on James Hutton, and then I will open up the multiple choice assignment for you, and y'all can complete that. Well, that took a lot longer. What time we get out of this class? In 10 minutes? All right. The assignment is open. Go ahead and go back into Discovery Education. You might have to go to the home page to see the assignment. It should just be 10 questions. I know you don't have a lot of time left.
Do we mark this one as complete?
Huh?
Do we mark this one as complete?
You don't have to. I once the readings are up there, I don't really look at them again because there's no grade attached to it. If you do that, it's fine. If you don't do it, it's fine. But make sure you're able to get to the multiple choice assignment. If anybody doesn't see it, let me know. Oh, it'll be in Discovery Education. Yeah, it should be up there now. Take your time on it. If you have any questions, let me know. I can help you during the assignment. It's just a daily grade. It's not like you should know the answer to this. I'll help you out. So if you got questions, let me know. Make sure you get it done. If you don't get it done before the bell rings, try to finish it for homework. Yes. Oh, that one. I thought they would say it in one of the videos. It's going to be December 31st. Just the idea is if you were to try to fit all of human history or all of Earth history in a year, humans and life wouldn't show up till the very, very end. Most of Earth history, there wasn't a lot going on as far as life is concerned. Okay, so for anybody watching this video from home, if you have any questions, send me an email. If you get stuck, send me an email. And I will see y'all for the next assignment.